Imagine an engineering structure so grand that it spans enormous distances, supported by just a few steel cables and colossal concrete towers. Suspension bridges are some of the most impressive human creations, connecting continents, cities, and economies around the world. Today, we'll follow the construction process of one of these engineering marvels. From the foundations submerged on the seabed to the towering spires that rise into the sky, you'll see how these giants are made. Get ready to discover the magic and precision behind the world's longest suspension bridges. Subscribe to the channel, like this video, and activate the bell so you don't miss any steps in this monumental construction journey. Let's begin exploring the incredible world of engineering behind suspension bridges. Before a suspension bridge begins to take shape, the first critical phase of construction takes place underwater, where the subsea foundations are established. This stage involves the creation of submerged caissons, large concrete or steel structures that are lowered to the bottom of the sea or rivers, where they will be immersed in the seabed. The process begins with excavation and site preparation, with large dredgers removing sediment from the seabed, creating space for the caissons. These caissons are then filled with concrete, creating a solid base that can support the weight of the bridge's immense towers. The process of installing the caissons requires precision, as the stability of the entire bridge structure depends on the solidity of this foundation. The bridge towers, which are the structures that will support the main cables, will be erected on top of these caissons. Without these solid and well-placed caissons, it would not be possible to proceed to the next phases of construction. The underwater work is meticulous and complex, and precision at this stage is crucial, as any error in the foundation can compromise the bridge's stability. As the foundations are completed, the towers begin to take shape, marking the start of the impressive journey of building a suspension bridge. With the foundations completed, the next phase involves the construction of the bridge towers. These towers are the imposing structures that will support the steel cables that hold up the bridge deck. The first step in erecting the towers is the assembly of enormous concrete and steel blocks that form the base of the towers. Using high-capacity cranes, large sections of these towers are lifted and connected one by one. Each suspension bridge tower needs to be built with extreme precision, as it must withstand the immense forces that the steel cables will exert on it. As the height of the towers increases, the work becomes increasingly complex. Workers need to move at great heights, often on suspended platforms, with reinforced safety and specific tools to ensure the stability of each installed piece. The material used is generally reinforced concrete or high-strength steel to ensure that the tower can support the weight of the cables and the bridge deck. Furthermore, the towers must be constructed with millimeter precision so that the cables can be installed effectively and in a balanced way, ensuring that the bridge has the necessary strength to withstand vehicle traffic and the strong winds that can be common in the regions where these bridges are built. This is a crucial moment in the process, where the bridge begins to take shape and approach the functionality that will be seen after its completion. Now that the bridge towers are firmly in place, it's time to begin installing the main cables. These cables are responsible for supporting the weight of the bridge and transferring the compressive forces from the towers to the bridge deck. Installation begins with the step of braiding the steel wires. Using a machine called a cable tower, thousands of steel wires are pulled through carefully planned systems. The cable tensioning process is crucial, as the exact tension needs to be applied to ensure the weight of the bridge is distributed evenly. After tensioning, the cables are connected to the tower pillars and the bridge deck. The work of the laborers and engineers in this process is fundamental, as any error in tensioning or installation can compromise the entire bridge structure. Once the cables are tensioned, they are reinforced to ensure they can withstand the extreme forces acting on the bridge, including wind, traffic weight, and weather variations. This is when the bridge begins to take its final shape, with the deck being suspended by the steel cables, which become the backbone of the structure. With the cables in place, it's time to build the bridge deck, the surface where traffic will pass. Deck construction begins with the installation of steel or concrete beams. These beams are transported to the site and assembled along the main cables, creating the structural base of the bridge. The assembly of the beams is done with millimeter precision, as any error in the installation can compromise the safety of the bridge. Throughout the installation, traffic lanes, pedestrian walkways, and support structures begin to be fixed. In addition, systems such as drainage and fire protection are also incorporated. Deck construction is the final stage where the bridge takes shape and becomes functional. During this phase, the work must be carried out with total attention, as the quality of each component installed will directly affect the durability and safety of the bridge. After the deck is installed, the bridge is practically ready to be used, but load tests and final adjustments are still necessary before it opens to the public. With the bridge deck installed, the final stage of the process arrives: cable tensioning and final testing. This is a critical verification moment, where the bridge needs to be tested to ensure all parts are functioning as expected. During tensioning, engineers adjust the cable tension to ensure the bridge has ideal strength and correct weight distribution. After tensioning, the bridge undergoes load testing to ensure it can support the weight of vehicles and withstand external forces such as strong winds and earthquakes. This process also includes vibration and flexibility tests to ensure the bridge will be stable under different weather conditions. During the final tests, safety structures such as guardrails and monitoring systems are also checked to ensure the safety of drivers and pedestrians. After the tests are successfully completed, the bridge is finally ready to be opened to traffic, and the monumental work is finished. The construction of a suspension bridge is a long and challenging journey, but when completed, it becomes an engineering landmark and one of humanity's greatest achievements.